Okay, we're going to look at transformations of functions. Have nothing to do with the transformers. We're going to look and see how we can do different translations, reflections, stretching, and shrinking. Typically in an algebra course, they have what they call toolkit functions, and these are your basic functions that you should be aware of, like the identity function, linear, quadratic, squaring, a root, the square root function, cubic function, cubed root, reciprocal, and absolute value. Because when we do transformations, you always start with this toolkit function, okay, and then you modify it depending on the translations. And so let's see how we do these. So if I have a vertical translation, they tend to be the easiest because if you add, it just picks the function up and moves it up the number of places with the constant here. So you can see the plus b. If it was a minus b, it would bring it down. The horizontal, sometimes students get a little confused because that's a plus 7, but it actually moves it to the left. So notice it. Notice here it says if it's x minus d, then it shifts d units to the right, but this was x plus d, in this case 7, so it shifted it to the left. We also have reflections, where if we put a negative in front of our function, it reflects across the x-axis. If we put the negative inside, then it reflects off the y-axis. And if we have a point, say that is on the graph, and we can either plug in the negative in front of the function or in front of the x, then we can see that we can even reflect points, not just functions. Vertical stretching and shrinking. So if I have a graph and I have a constant out front, if this constant absolute value is greater than 1, then it's stretching it vertically. If it's less, between 0 and 1, stretching this function as well. If it's less than 0, notice the graph is also reflected across the x-axis, but we can find these coordinates based on, just as you did before, plugging values into the function and plotting points. So notice our vertical stretching and shrinking has to do with the value outside the function, a constant, where the horizontal stretching or shrinking has to do with a constant inside the function, right? And so you can see the values for shrinking and stretching as well.